Turn to test to you, and there's some questions that I ask you to be able to do that I was surprised that you weren't able to do as we go ahead and think in terms of the simple interest unit. So this is just some follow-up in that. We're going to start a new unit today. But on simple interest, I ask you the following questions. How many times a year are you going to compound interest when you do it quarterly? And the answer? 4 times a year. You do it every 3 months, so that would have been a 4. How many times are you going to compound if you do it semi-annually?
2.
You do it every 6 months, so that's 2 times a year. If you're doing daily, 365. If you're doing monthly, 12. And annually, once. That was a 20-point question. And something that you should have picked up from the unit. So the simple interest unit, you need to go back and spend some time on. Now, I'd also like to look at the last question that it was involved here. And this is where, I take it back, it was the third question. Okay, this was in the third question where you put the following, $10,000 in a bank, and you're going to do quarterly compounding, and you want the amount of money at the end of a year. You'll need out your calculator. I want to look at this briefly. And to start this problem, I'm going to go to the sideboard. And just a reminder that if you're going to do something quarterly, you're going to do it 4 times a year. So I'm going to go to this table, which you were supposed to have looked at. This is on page 174. It's what I just talked about. Compounding interest, the compounding period, the number in a year. So this is what we talked about. Now I'm going to look at doing $10,000 in number 3, yes, $10,000. So we're going to do that for $10,000. Let's take the principal. As we go to the sideboard now. So I'm going to do it for $10,000, the interest rate. And I'm going to change this slightly because I want to look at another problem. So I'll wait for Will to catch up with me here. Okay. And we make the cut. R is going to be at 8% because I want to look at this problem if we do it for a year, but we do it daily. But for the moment, you're going to need your calculator here. The rate of interest is 8%, and we're doing it on a quarter every 3 months, so that means T is 1/4 of the year. So if you want to find the interest at the end of the first quarter, you should be able to take this $10,000, you should multiply it by your 0.08, and then technically you could divide by what?
4.
By 4, rather than multiplying by 1/4. It amounts to the same. So what do you get for that interest for the first year? Seems a little bit high. 10,000 times 0.08 and then divide by 4 equals. Let's see what you get. Is exactly $200 that fast?
Yeah.
Okay. Exactly 200. Okay. That makes sense. So how much do I have in the bank? 10,200 at the end of 3 months. So this is what I would have for the next 3 months. And so what would I do with that? I'd multiply that times 0.08, divide by 4, and I get a new interest. Now, what I want, and we've done this, what I want to do is change the way you approach the problem. I want to look just at this much. Remember we said we had 10,200. So I had 10,000 plus the interest, which was 10,000, times my interest rate divided by 4. Agreed? I'm going to rewrite this in this way. Look at what I've done, because this is very critical to this unit. 8% divided by 4 is 2%. Agreed? Now, if I look at this, I have 10,000 times 1 and 10,000 times 0.02. If I just did this, take the 1.02 and multiply by 10,000. Will you do that in your calculator? Take your 1.02 times 10,000. Do you get the 10,200 again? Yeah. That's a nice shortcut. So if I want to find the amount of money in the bank at the end of 1 year, here's what I do. I take this 1.02 to the 4th power times my 10,000. So the question is, how do we get 1.02 to the 4th power? Will you do this for me on your calculator? 1.02 times 1.02 times 1.02 times 1.02. Find that for me. And then when you get done, I want to multiply that by 10,000. So when you take 1.02 times 1.02 times 1.02 times 1.02, what did you get, Adrian? 10,820. No, I want to know just what 1.02 times 1.0. 10824. 321. And I'm multiplying that by 10 to the 4th. So what do I do to the decimal point? Move it to the right. How many places? 4 places. So what does that give me? Okay, so $10,824.32. $10,824.32. Now, just looking at the angle there, I don't like the way that reads. So I'm going to try rewriting that part. 10,824.32. Let's see if that reads on the camera better. Yes, it does. Okay, now let's see how we can do that without having to multiply these out each time so we can make it easier. I want you to go ahead with your calculator and do this for me. Enter 1.02 and hit M+. So you have 1.02 and you enter M+. You should see an M on your keyboard, right? Or on the output. Now here's what I want you to do. I want you to hit times memory recall times memory recall times memory recall. So that is 1, 2, 3, 4. And at that point, you should see on your readout 1.0824321. Do you? Again, now this assumes you have a 4-function calculator. Exactly 4 function. Okay, if you do, you should be able to turn it on and off, back again on, and start with 1.02 and put it M+. Then when you hit times MRC, maybe you have to hit an equal in the last one. So let's try an equal sign down here. That may be necessary. So M+ times MRC times MRC times MRC equals.
How many times you do that?
You're hitting the MRC 3 times. So your first, when you had your 102 upstairs and you multiplied by MRC the first time, you got it to the 2nd power. Are we getting it? Got 1 who did. Anybody else?
I did.
2 of you, 3 of you? Anybody else? Getting it? So if I wanted to change this problem to the following, I want the amount of money at the end of 365 days, compounding daily. How would it look different? That's what I want to look at. So I'm going to leave this where it is, Will, and I'm going to go up to the front of the room. Here's the same problem. So at this point, if you just want to go to camera 1 here temporarily. So camera 1, we're going to bring in the same problem that I just talked about, and here's what it says. 8% compounded daily. So what I have to do is take my 0.08 and divide by 365. Okay, so that's what I'm going to do. And we're going to slide over here and bring it up just a little bit. There's the number. So take your 0.08 and divide by 365. You should get 0.0002191. Do you? Are we in agreement? And if I were going to play this game, let's slide over a little bit more now. Over to here. Or are you going to go to camera 2, whichever way? Okay, go with camera 2 then. Put this into your calculator at 1. Otherwise, we add 1 to that number. So, in fact, let's slide over a little bit, Will, so I can just see this much here. Okay. So I took my 0.002191 and I added 1 to it and get this number. I put that in memory. M plus, same way. And then I would hit times MRC times MRC. How many times do I have to do that?
3 times.
364 times before I hit the equal sign. Now, well, this is going to be a little bit messier than I'd hoped. What camera are you on now? Go ahead and bring me on a number 1 here so I can go back to what I have in the sideboard with number 2, because I need to compare these two. Now, what I want you to compare is what I have here. The idea of you're taking this 1, okay, I'll wait for, thank you. Take this 1.0002191, you put it in memory, and then you hit times MRC 364 more times before you hit your equal sign, and you'd have the amount of money in the bank 1 year compounding daily. Let's go back to what we were in the sideboard where we had the same 1.02 M plus times MRC. Let's pick that up. Now this problem on the sideboard was doing it just 4 times a year. So this isn't too shabby, right? If I look at this, all I have to now do is multiply this times 10,000. So that means I move the decimal 4 places to the right. So I have 1, 2, 3, 4. So I have $10,824.32 in the bank at the end of 1 year, doing it 4 times. But notice, I take my point, no, I need the other way on that, Will, if you could, please. Otherwise, I needed to come back here and take my what? My 0.8 and divide it by 4. That's where I got the 0.2. Then I added this 1 with the 0.2, and that's where I get this 1.02 that went up here. Now back to the front board. Same idea, but this time I had to divide 0.08 by 365. Then I added 1 to it and got this amount up here for my 1.0002191. Do you understand how impractical it is to do this 364 times? Now I'm going to show you how with a different calculator we do this. And then understand, this is compounding daily. That's not what the banks are doing now. They do it continuously. Every second. Every microsecond. But just doing it daily. Let's come back to the document cam, Will. And then I'm going to be basically working up here now, so you can bring camera 2 back up here, camera 1 center, and let me go to this calculator. Now this is a Hewlett-Packard 21S. Happens to be one that I use in stat. It's no longer made. They used to make a 20S until a year or so back. Now they don't even do that. But do you see this key called y to the x? Right there. So if I want to take my 1.02 to the fourth power, look how I do it. So I'm going to turn it on, and I'm going to do your 1.02. Then I'm going to hit y to the x. Here I want to do that 4 times, fourth power. And there it is, my 1.082432, and there's more garbage after it. That's the same number I just had on the sideboard. Okay, so that was the shortcut. Now, what I'm going to do is take my 0.08, coming back to the calculator, I'm going to divide by 365. And this is the number we had on the board. I'm going to add 1 to that. Add 1. And there's my 1.000. And Will, you can show that number right up here. So bringing camera 2 back to show me that number. Okay, this is the same number we had on the board. And instead of multiplying times MRC 364 times, I'm just going to take that number on the calculator back now to 365 times. So I'm going to hit y to the x. 365 equals 1.0832775, and we're going to see that number here on the board. And I multiply that by 10,000. And notice how much I get 1 year daily. So I have $10,832.77. Remember when we did this on the sideboard, we had $824. So I gained $8 doing it every day. I can make even more money. This was doing it each day. Now that's what we did in the unit. And what I want you to realize, if you do it in a bank these days, as we come back to the calculator, you see another key in the calculator. It's called e to the x. That's this key right here, e to the x. So if I want to find the amount of money that I have in the bank at the end of 1 year, compounding every instant. I had 8%, right? That was my interest rate. So watch what I do in the calculator. 0.08. That's your interest rate. Now, hit this e to the x key and multiply that by 10 to the fourth. And so what do I get if I do it every moment of the day? Well, this is the number we get. $10,832 and what? 87 cents. I get 10 cents. Now, I brought up an interesting problem in the last hour I want to talk about. Here's the problem. Somebody gives you $10,000, okay? Just like we have here. And you're at the age of 25. Somebody just hands you $10,000 and you say, I'm just going to put it in the bank. And you were fortunate enough to put it in an account that gave you 8% interest. Continuous compounding. How much money would you have when you retire if you don't touch the money in the bank? So you put it in the bank at the age 25, and you let it sit there 40 years, and you retire. Here's what you do. You take your 0.08 and multiply by 40. Okay, so let's come back to the document camp. We're going to take our 0.08 and multiply by 40. So let me enter that. 0.08 multiply by 40 years. and I get 3.2. Agreed? Watch what happens when I hit e to the x. Now move the decimal 4 places to the right, and how much money do you have in the bank 40 years later? You did nothing other than simply put it in the bank. Let it sit there for 40 years, compounding continuously. And we're going to go to the figure on the board. This is multiplying that. I need to pick up this figure up here, Will. Higher. There we go. That means I would have $245,325.30 in the bank. So I take the $10,000, put it in the bank, do nothing. But I keep getting my 8%. Now that sounds like a pretty good deal, right? $10,000 in the bank gives me $245,000. So question. Let's say you could do this 4 years in a row. Age 25, before you're 30, you put $10,000 in the bank each year. Roughly speaking, and that's called an annuity, where you put that much money on a yearly basis. You have 4 good years. So you put $10,000 in the bank for each of 4 years. You would have $1 million at that point when you retire. Well, you can't do anything with it for 40 years. Now, by the way, that sounds pretty decent, but as I'm going back to center on this, you need to keep in mind there's some other things that happen on the way to the bank. 40 years. This morning in the Modesto Bee, there was an edition on new cars, new car preview. So I just browsed that over a cup of coffee this morning, thinking about what I wanted to do today. And I looked at the price of new pickups. Now, this isn't everything on the truck, but just a good typical truck, about $30,000 to $35,000. Let's go back 40 years ago, 1966, 67. How much was a pickup that had everything on it? Lower than that. About $3,000. 1966, 1967, if you wanted a pickup with everything on it, you couldn't get all the things on it now that you can get. They didn't have DVD players then. Okay, so that wasn't an option. And you didn't have all the safety stuff, and you didn't have the airbags, and but you had a nice truck. $3,500 get you a really nice truck. Now it's $35,000. Now my point being, if you could buy something now for $10,000 and we jump the 40 years ahead and the same thing happens that's happened in the last 40 years, how much is something going to cost you then? $100,000. So $245,000 may not seem like a bunch. I think when I was a child, my parents, when I first was born, took out one of these annuities, sort of like a life insurance policy that would mature at 20 years. And they took it out, and it was $1,000 that would, at the end of 20 years, would be available to me. They were thinking when I went to college, in 20 years, that $1,000 would be something. By the way, a loaf of bread was 10 cents when I was like 5 years old. Okay? A cup of coffee, a nickel. And that $1,000 seemed awfully big. I remember my dad's paycheck then. He earned $2,000 a year. That was a good job. $1,000 seemed like a lot of money. Okay? When I went to school, that took care of 1 year of the dorm. Just to live on campus for 1 year, not 4 years. So we have to be careful what we set aside, is my point. And you look at the interest you get, and it sounds like at $245,000 you're sitting pretty, because that's a lot of money if you can put it in the bank and get interest. But if it takes 10 times as much money to live 40 years from now, it's not so much. Well, that was the unit. And that was trying to bring to your mind what happens with interest. The results in the test were not as strong as I hoped. We had some real problems on, just as I say, quarterly, semi-annually, otherwise going back to the document cam. On the document cam, we have these number of times you compound in a year, and this is something that you didn't pick up on, and I asked you in the test, and it cost you considerably not being able to do that. So let me talk what's happening, or what will happen at the end of this week. We're going to go to Unit 4 now, which is called Large Numbers and Scientific Notation. And on Thursday, we're going to have a test on it. It's a short unit. And I basically expect with what we do in the next half hour that you can do most of this unit without a problem by Thursday. The test on Thursday will only be about 30 minutes on this much of it, maybe even less. And I will give you an opportunity on simple interest to retake that test on simple interest on Thursday also, but it'll be a half-hour test also. So those two things happening on Thursday. So large numbers and scientific notation. The motivation for this unit happened to involve my kids because I was reading a book to them from the infamous Dr. Seuss. It was called The Sleep Book. And I started thinking about this problem at the time that I was reading this book to my kids. And it was the Who's Asleep score. And so the idea in this book goes something like the following, and now adding things up. Okay, so let's come off there just for a moment, Will, so I can get this so I can move the book around. And now, adding things up. We are way beyond billions. Our Who's Asleep score is now up in the zillions. Okay, that was from Dr. Seuss. In the Who's, see, the title is The Sleep Book, and it's Who's Asleep score. Now that book, by the way, was written in 1962, and I think is still available to be read to kids 40-some years later. Dr. Seuss, The Cat in the Hat, Green Eggs and Ham. How many of you had stories read to you from those books? Just out of curiosity, how many? Raise your hands. That's it? Okay, a little more interesting. I still read them to your kids, and Sarah has read them enough times, she has some of them memorized nearly. Okay, so if you've had your kids and you read them The Cat in the Hat, you may have pieces of that. Green Eggs and Ham.
My kids ate green eggs and ham.
8 green eggs and ham. Okay, brought it in for them. Sam I am. Now, what is a zillion? Not a real number. It's just a bunch, right? What are other words besides zillions that we use? Bajillion, gazillion. Anything else? A zillion, a bajillion, a gazillion. Anything else? Anybody else come up with one that we haven't said? A whole lot? Out of curiosity, because some of you are bilingual, is there a similar word that you use in Spanish for zillion or jillion? Anybody? Do you think of a similar word that you would use? No? I can't. It surprises me if that's just something we do in the English language, because I'd be really curious if in other languages there is a similar way to deal with a very large number. Okay, nobody has a word for me. Back a number of years ago now, there was a mathematician. This is back in the 60s. This is the mathematician. Dr. Edward Kasner came up with a number, and he asked his nephew to name the number. And the nephew was in kindergarten. And this is now more famous than ever before. As we go back, it came out of Google. Now the Google that you're familiar with is spelled a little bit differently, correct? Google. It's the search engine on the internet. That's a result of a spell check error. The people who created the Google expected it to be spelled this way. And in an interview I heard with the owners of the company, my understanding is they were doing letterhead or something, and somebody did a spell check. And it was changed to Google, and hence the name of the website. But it was to be named after this number. So the question, Dr. Kasner was trying to think of the largest number that you might need. Largest number. And so he came up with this, a Google, and it was a 1, and there are 100 zeros after that number, after the 1. 100 zeros. So with 100 zeros, we know how we can write that as a power of 10. This would be a 10 to the 100th power. And that is how we would write a Google in this notation. Powers of 10, known as a Google. Now, if you have a 1 with 100 zeros after it, that's a pretty big number. And it's hard to get a handle on it. So to get a handle on it, what Dr. Kasner did was create one more number and then ask his nephew to name it. He said, let's have a Google of zeros after the 1. Now this is what a Google is. It's a 1 with 100 zeros, correct? And then you want to put that many zeros after this 1. Now let me caution you. It's not 100 zeros. Think of 10 to the 100th. And then think of 10 to the second. If I ask you to do something 10 to the second times, that's 100 times, correct? Again, if I ask you to write 100 zeros, that's 10 to the second. Only 2 zeros. If I ask you to do something 1,000,000 times, 10 to the 6th. But here we have a Google of zeros after the 1. And this is named the Googleplex. By the way, the name of the corporate headquarters for the search engine is called a Googleplex. So they played on this number quite a bit. So to get an idea of how hard it would be to write a Google of zeros, I ask you to do the following. So what I need to have you do is turn the page now. Turn the page in your book, one more page. Let's see, what page are you on now? Turn to page 85, I hope. Problem 4. So page 85, bottom of the page. Page 85 at the bottom of the page. Waiting for you to get there. Page 85, bottom of the page. There is some space, and in that space, what I ask you to do is to write zeros for 1 minute as fast as you can. So we'll take time, for those of you at home who are watching, maybe grab a pencil and get a piece of paper. And what we'll do here in just a few more seconds is have you write zeros for 1 minute as fast as you can. So in about 7 or 8 more seconds, we're going to start. Get yourself ready. You're going to write zeros for 1 minute as fast as you can. Get ready, get set, go. And so what's happening as we wait here, we're watching the clock. We're writing zeros as fast as you can for 1 minute. You've got 10 seconds gone. 15 seconds. Write zeros as fast as you can. You're up to 20 seconds. Don't worry about your hand cramping. Just keep writing. Okay, you won't get carpal tunnel out of this. So you're at 30 seconds, halfway there. Keep going. We're at 35 seconds. Writing zeros as fast as you can. Some of you are really whipping them out here. Okay, we're at 45 seconds coming up at 43, 44, 45, 15 more seconds. Don't quit. Writing zeros. And we're getting down to the last 5 seconds here. Okay, 5, 4, 3, 2, 1, stop. Can you picture doing that for a year? Non-stop? Okay. Now, here's the question. How many did you write? Okay, so let me write down some numbers. Adrian, you said 140. Teresa? 119. Okay, so Adrian's got the record so far. Okay, we'll see what we can do. Number of zeros. Waiting to get some counts. Okay, still waiting for some numbers to come up here. 140 is a record. If you can get more than 150, you are moving. But 140. What is it, Leanne? 155. You are trucking. 155, new record. So Leanne has 155. Who can beat that? What are some of the other numbers? Just to get an idea of what we have going here. 149. Very close. Okay, another number. Anybody else? Rose? 133. Okay, anybody else?
189.
What? 189? Holy cow. 189. Write small circles. That's the idea, right? Doesn't take us long to draw small circles. That is a new record. Sorry, 155. We're at 189. Okay, who else has a number? Anybody beat 189? That's awesome. Very small. Like periods.
Yeah, just about.
Sheesh. Okay, I've never thought of that. Make your circles smaller, make more. Okay, so 189. Now here's the question. If you could keep up that pace, 189 a minute, how many would you do in an hour? So let's take out the calculator. So this is the number in 1 minute.
11,340.
You know, let me write this down. Okay, so give me the number. 11,340 in 1 hour. What did she multiply by?
60.
Multiply by 60, right? Okay, let's go now for 1 day. How many hours in the day? 24. So you just keep this pace up. You don't rest. So how much do we have in 1 day? 260,820 in 1 day. But let's keep this up for a year. So multiply this by what? 365. We'll go 365. Do you disagree on the...
I got 272, 160.
Okay, 272, 160. 272, 160. Okay, now let's go for the year times 365. 99,000. No? Okay. Scratch that. What do you have, Travis?
99338.
338400.
I got 2.
Do we agree? In 1 year. Okay, so it looks like nearly 100 what? This is 99 what? Million, right? So roughly 100 million. That would be what? 100 million. Otherwise, we'll speed the pace just a little bit. 189, we'll kick it up to 190 or something. Just a few more zeros is all you have to do. Now, that in 1 year.
That's a lot.
Okay, now let's ask this question. That's 10 to what power? 10 to the 7th. Do we agree? A little bit more than was done, but we'll go with 10 to the 7th. Now, let's kick around the age of the earth as we argue somewhere around 6 billion to 10 billion. Let's take its worst case, that this old universe that we think of has been around for 10 billion years. Okay, how do you write 10 billion? 10,000 million billion. That's how much Bill Gates, I think, is worth, somewhere around there. So 10 billion. So what is that? 10 to the what? 3, 6, 9, 10. So let's say that you have been doing this many per year for this many years.
You count that 0 on the 10?
Yes. Otherwise, you want to know how many zeros after the 1. And after the 1, there are 10 zeros.
7 on the
Up here, then this should be what? 10 to the 8th. I didn't pick up on that. That should have been 10 to the 8th. I didn't catch that error because it's the 1 followed by the number of zeros. Okay, so if I multiply these two together, what do I get? 10 to the 18th. That's how many zeros you've managed to write. In 10 billion years, writing 100 million per year. How many people are on the earth right now? Well, we're at about 6.5 billion. So let's assume we're going to increase that amount shortly, and let's say there are 10 billion people. So I get to multiply this times 10 to the 10th. So now I'm up to what?
28.
So if we could write zeros at a little more than 189 a minute for a year nonstop for 10 billion years with 10 billion people all writing zeros, we would have managed to have written 10 to the 28th zeros. To get a Googleplex, what do you have to do? Write a 10 to the 100th zeros. We haven't even begun. Okay? Get the idea? Now, the Googleplex, slide back over here. I can still write as what? 10 to a Google, even though I could not write it in positional notation. Now, let's talk briefly about how to name numbers, because this is part of this unit. We still haven't talked about scientific notation. I'm going to slide back over to the right, since we're doing fiction here. We talk about movies. If you look at old movies, and you look at when they're done, you oftentimes see what we call the Roman system. Okay? And so let's slide back a little bit more towards this side, get rid of the blue for a moment. Okay, that's getting better. MM means 2000. So this year is MMVI, 2006. Now the Romans used an M for 1,000. Interestingly, in our current newspapers, if you see an M, it many times stands for millions. But the Roman system, an M was 1,000. So how would you write 1 million in the Roman system? You'd have to write M 1,000 times. Or bar M. A bar M meant 1,000 thousands or a million. So this was 10 to the 6th, which was 1 million. Remember, this is 1,000, and then just put 3 more zeros, it's 1 million. What would you have if you had 1,000 thousands? 2 bars. 10 to the 9th. And we would call this 1 billion. I'm just going to write it out. So here it was 1 million. We'll just do one more. We'll try to get to the national debt. That's M bar bar. That's 1,000, thousands. 10 to the 12th. 1 trillion. And that's where our national debt is at this point, in the trillions.
That's, I thought it was like 3 trillion.
Yeah, but it's in the trillions. Now, how many bars? 3. If you have TRI for tricycle, triplets, so TRI, illion. So a trillion or a trillion. Now, if you go for bar, I need a bigger, more space. If you go for an M, bar, 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 what should that be? That's 1,000 trillion, which quadruplets would be a quadrillion. That would be 10 to the 15th. So if we want to name a number and we forgot how to do it, start with 1,000 and ask how many bars you have above it. So let's come up to here. We don't say bwins, we say twins, unfortunately. But biweekly, bicycle, 2 wheels, biped. So this is the billion because of the 2 bars. So this was quad. And so if you just look at the bars, it tells you how to name a number. So if you went to the next, it would be quintuplets or quintillion, then sextillion, septillion, octillion, nonillion, decillion, and you just, hopefully we'll never get there with our debt. But that's the way you name these numbers. Now, a monocycle, million. Okay, a monoped. So the idea is 1 bar, 2 bars, 3 bars, just count your bars. And each bar adds what? 3 more zeros after the original 1,000. So M is 1,000. A bar over it means add 3 more zeros. If you can do that, you can name any large number without trouble. And write it as what? A power of 10 and give its name. So remember, this was trillion, so this is 1. Quad, and we actually put rillion rather than quadillion. And I'm not sure why, but quadrillion sounds better than quadillion if you just listen to it. Okay, how are we doing? I just ran out of time and I ran out of numbers. What we're going to do tomorrow is work with scientific notation for big and small numbers. And you need to be working on this unit because by Wednesday you should have it done, and that's not too hard to do. So we're back to the Blues Brothers, and we're going to do Jailhouse Rock. It's number 11, I believe.